All right, so last time we left off on working on sum and difference identities. I believe that's where we are, right? Yep, sum and difference formulas. And we had done two different formulas where we took something that was not an item that was on our unit circle, and we added two values together, two angles together, and we said, but it would work if I added these two angles together and these two angles were on my unit circle. I want to show you a similar argument, but this is a little bit more direct. So on this one, what you'll notice is you've got, if you just tried to solve this directly, you've got pi over 12s and 5 pi over 12s, and those are not on your unit circle either. Because on your unit circle, you've got things in 6s and 4s and 2s and 3s and not 12s. But this actually fits in with one of the forms on this sheet that you have quite well, right? So which one of these identities is this from the front? Yeah, it is the sine of alpha plus beta, right? No, sine of alpha minus beta? Minus, it is. Okay, sine of alpha minus beta. It fits the description on the right-hand side of that because I have sine of alpha cosine of beta minus the cosine of alpha sine of beta. So I'm actually going to use that identity, but I'm going to sort of squish it back together instead of expanding it out. Okay, so doing basically the opposite of what we did on the last problems. So it is what we just said. The sine of alpha, which is pi over 12, minus beta, which is 5 pi over 12. So far, so good? Okay, that's an identity that allowed us to do that, not just us looking at it and saying, oh, I have subtraction, and so it's subtracting these angles, because it doesn't work that way all the time. For instance, if you look back over here at these identities, if you had the cosine of two things added together, it actually ends up being subtraction and vice versa, right? So the identities are what we're using to make this claim. But this is good from here because what is pi 12ths minus 5 pi 12ths? That would be 4 pi 12ths, but it would actually be negative 4 pi 12ths, right? So this is the sine of negative 4 pi over 12. All right, so how about 4 over 12? That reduces, yeah? Negative pi thirds. So this is sine of negative pi thirds. If you really want to deal with it with the negative, you can. What else could you do?
Put it in front of sine.
You put the negative in front of sine, and then you can work in quadrant 1. Okay, so these is sort of an optional step right there, but often we want to think that way, and so it's a good step if we'd like to do it. And then what is the sine of pi thirds? Because that's on my unit circle.
60.
That's the 60-degree angle. What's the sine of it? Somebody's saying it. Square root of 3 over 2. So the negative from the front stays negative, and then I have square root of 3 over 2. So I can use my identities to make the problem significantly easier on this problem, right? Because prior to this section, the best you could have done was approximate this. Because you don't have pi over 12 and 5 pi over 12 in your unit circle. Okay, so this is a nice example of how you can simplify with these. Now, I'm giving you a nice example right before something that's going to be a lot of work. Okay, so you ready for a problem that's a lot of work? It sounds like a fun thing to do on a cold morning, so we're going to do something with a lot of work. All right, so you're going to find the exact value of 4 different things. So although it doesn't really say it, this is actually 4 problems in one. Okay, so let me label them, and I'll label them A, B, C, and D. And more than anything, this is a lot of work because I'm doing 4 problems, not because the problem itself is a lot of work, okay? And I'm doing this under some conditions, and you do have a couple of these on your homework. So when you're seeing this, be prepared. These problems are going to be ones that are going to take a while because you're really doing 4 problems. You're given some conditions. You're told that the cosine of alpha is 1/2. And that alpha is in the quadrant where negative pi over 2 would be the minimum and 0 would be the maximum. It's telling you that the sine of beta is 1/3, and that beta is in quadrant that would be associated with the angles from 0 to pi halves. So the first thing I want us to do is to identify in our minds which quadrants we're in. Alpha. What quadrant is alpha in?
4.
That is 4, right? So this right here tells me I'm in quadrant 4. Let me use red just so that we can see it quickly. And how about beta? What is beta? What quadrant? That's in quadrant 1. Okay, let me see how many slides I gave myself to work. Oh, good. I gave myself lots of slides to work. Okay. See, I learned from last time, and I said I need lots of space. So the first thing I need to do is I need to work within those quadrants because I'm supposed to be finding sine, cosine, and another sine, and a tangent, and it's all those same trig identities that were on this front of the sheet. Okay, so flip back to the front of the sheet and take a look. If I were finding, let's just look at part A, sine of alpha plus beta. That's the second one on the left. Yes? What that means I need to know is I need to know what is the sine of alpha, what is the cosine of beta, what is the cosine of alpha, and what is the sine of beta. And I know two of those things right now. But I don't know the other two, right? Okay, so I have to actually find all four pieces of that information in order for me to progress any further. And the easiest way to sort of tackle that and find all those pieces of information is to draw triangles that show all that information. Make sense? All right. So the first one I'm going to draw for alpha is actually going to be in quadrant 4. Okay? So I'm going to draw a triangle inside of quadrant 4. All right. Let's just do a freehand. All right. So I've got an angle theta, or I'm sorry, alpha. Let's use right angle alpha here. And that alpha is supposed to give me a cosine of 1/2. Where does 1 go? Where does the half go? Where does the 2 go?
On x-axis.
Good. Excellent. And you may, off the top of your mind, remember what that third side would have to be. It is square root 3. And if you don't remember it, how could you find it? Pythagorean Theorem. Okay, so this one's actually fairly nice. It's actually a 30, 60, 90 triangle, right? So that's actually why we are sort of remembering that square root of 3. But what I also want to identify is the extra piece of information that I need from this. That is, I need to know what the sine of alpha is, and in a little bit when I do part D, I'm going to need to know what the tangent of alpha is, so I might as well get that right now too. So what is the sine of alpha from this triangle?
Negative square root of 3 over 2.
Okay, and I actually need a negative. I didn't get that written down, did I? That's negative square root 3 because I'm down in quadrant 4. Thanks, Lauren. All right, so I actually have on sine negative square root 3 over 2. How about tangent? What is tangent?
Negative square root of 3.
Right. Okay, is that good for everyone? Okay, I'm going to try this one more time. Did I have 4 extra slides or just 3? 1, 2, 3. I have 3. Okay, so I need to use one of them for this. Okay. I need to do one more set of triangles. I need to do a triangle in quadrant 1, correct? For my angle beta. So I need to be in quadrant 1 for beta. And here's beta right here. Whoops. And it's supposed to be sine of beta is 1/3. So where does my 1 go? Where does my 3 go? 1 goes on where? The y. Good. And then 3 is the hypotenuse. Now this is not on the unit circle. At least not one of our standard unit circle values, correct? So I actually am going to need to use the Pythagorean theorem to find side 3, or whatever, the third side that I don't have. So let's call this little c down here, not c. How about b? All right. So we have 1 squared plus b squared equals 3 squared, yeah? So this is 1 plus b squared equals 9. What is b squared going to equal? 8. What is b going to equal?
2 squared.
Right, so when I square root this, I don't get to leave it a square root of 8. We did this back in chapter 2. I simplify this, and because this 8 is the same as 4 times 2, the square root of 4 is 2. This is 2 square roots of 2. Again, from this piece of information, or from this triangle, I also need 2 pieces of information. I need to know what is cosine of beta, and I need to know what is tangent of beta. So what is cosine of beta?
2 radical 2 over 3.
Right. So this is 2 square roots of 2 over 3. How about tangent of beta?
Square root of 2 over 4.
Yes, Lauren's already simplified for us. So remember the way we do this is we have the opposite side, which is 1 over 2 square roots of 2. If I rationalize this and multiply by square root of 2 on top and bottom, it will become exactly square root of 2 over 4. Okay. I need all 4 of those. So I found 4 things here so far, right? I found these 2, I found these 2, and I had the original 2 up here. I need all of that in order to be able to do this problem, because I have 4 parts to it and it all involves those different parts. All right, we're going to take a look at sine of alpha plus beta. Are you ready? Okay. So part A, or the first part or whatever, was sine of alpha plus beta. And what does that formula say the sine of alpha plus beta is? Somebody just tell me in alphas and betas exactly what it says.
Sine of alpha cosine of alpha beta plus cosine of alpha sine of beta.
Okay, is that all right so far? The red's pretty good. You guys can see that all right, yeah? Okay. All right, so sine of alpha, well, I already had that, or I found it, one of the two. What is sine of alpha? Negative square root 3 over 2, right? It's the first thing I actually found. What is cosine of beta? Yes, it's 2 square root of 2 over 3. And I have addition. Now I need the cosine of alpha, which is 1/2. It gave me that information, right? And sine of beta, it actually gave me that one too. What is sine of beta? 1/3. And I mentioned this last time, and I'll mention it again. The nice thing is when we're working with sine and cosine for these anyway, the denominators are going to match, right? What's my denominator going to be for both pieces? 6. So if you don't get them to match, you've got an error somewhere. Should be a red flag going off. Oh, I got a 4 and I got a 9. I put something in the wrong spot. Go back, find it, because you do have an error, okay? All right, so I actually have what for the first fraction?
Negative 2 square root of 6 over 6. So just square root of 6, negative square root of 6.
Nope, you were right the first time. It won't simplify like you were describing.
Okay.
But even if it did, Lauren, we wouldn't want it to right now because we want to combine it with that other fraction.
Okay.
So we need that denominator to stay put. Yeah. And then the other fraction is actually 1 over 6, yep. And I'll go ahead and combine these on the right-hand side here since I can allow myself a little bit more space. This would then be negative 2 square root of 6 plus 1 over 6. Is that one all right? Okay. We have another one to do on this screen so that I can have enough space. Part B. Part B was cosine of alpha plus beta. All right, so somebody's going to flip back for me and tell me what is the formula for cosine of alpha plus beta, just with the alphas and the betas and everything in it.
Cosine alpha cosine beta minus sine alpha cosine beta.
Thanks, Aaron. Okay. Does that look okay? Did I get it all right? Okay. Again, I know all these pieces of information, right? They're all on the previous slide. So what is cosine of alpha? 1/2. What is cosine of beta?
2 square root of 2 over 3.
How about sine of alpha?
Negative square root of 3 over 2.
Okay, good. And sine of beta?
1/3.
1/3. And notice again, I've still got a denominator of 6, right? On all the pieces. All right, so we're going to do some multiplication. On the first one, I would have 2 square root of 2 over 6. What happens to my signs on the second one? They do become plus, right? Because I got 2 negatives, so I will end up with a positive. So this is going to be plus then. And then I have square root of 3 over 6. This will become just 2 square root of 2 plus square root of 3 over 6. resist any sort of temptation in your mind of thinking you can combine that square root of 2 and square root of 3, because you can't. The only way you can combine square roots is if if the value underneath them, under the radical, that's called a radicand. If the radicand is exactly the same. So if I had square root of 3 and square root of 3, sure, I can combine them. But I can't because one of them is square root of 2 and the other one is square root of 3. Okay? All right, we're going to do C. C was very similar to A. It is sine of alpha minus beta. So somebody's going to find out for me, what is that formula for sine of alpha minus beta?
Sine of alpha cosine of beta minus cosine of alpha sine of beta.
All right, so let me stop right here and make a comment. So you notice I'm asking you to write down what the formula was. If you choose not to do that on your work, that's okay. However, it's a good thing to do, because if you write down the wrong formula and I know that the reason you messed up is because you just wrote down the wrong formula, I can give you more partial credit, right? Because you knew what all the values were, you just looked at the wrong formula to start with. If I don't know what formula you're using, then I don't know if you understand the process that's going through after that. Does that make sense? So it's kind of a in your best interest sort of thing, but it isn't required. If you just jump into the next step, it would be okay as long as you have all the right pieces in the right places. So what is sine of alpha?
Beta square root over 2.
Okay, good. How about cosine of beta? Someone else for me. Okay, thanks, Michael. 2 square root of 2 over 3, right? Someone else for cosine of alpha. 1/2. Yes, it is. And one more person for sine of beta? 1/3. Thank you. All right, so these are all of our pieces. Got a little bit more space on this slide. What does the first one simplify to? So I've got a -2. And it is square root of 6, so I can multiply the square root and what's underneath the radicands, right? Underneath the radicals, I can multiply those. It was just the addition thing I was pointing out before. So I do have square root of 6, and then it's over 6, and then I have minus 1/6, right? So what does my value end up being? -1, right? And that is almost the same thing as I got for part A, isn't it? Yeah. It's just different by sign, the middle sign, which should make sense because it was all the same values in all the same places. It just had a sign difference in the middle of that formula, didn't it? So if you've already got one of them, you should get the second one without even doing any of the work we just did, if you did the first part correctly, right? Yes. So you can treat that one of two ways. You can either treat that as this is a good opportunity to check my work, and I can check to make sure that they do actually end up equaling. Or you can treat that as I already did all the work and I knew I did it correctly on part A. I can just write down the answer for part C and just change the sign in the middle. And that's appropriate and okay as well. All right? So either option. But no matter what you did on the first parts, part C, or D rather, we end up getting more work. So this is tangent of alpha minus beta. I'm going to do the problem with the formulas, but let me tell you something else you could do. Let's suppose for a moment that instead of being asked to find tangent of alpha minus beta, I was asked to find tangent of alpha plus beta. Okay. Well, I actually can find tangent for a particular angle if I know sine and cosine, right? What is tangent? Sine over cosine. So if I had been asked to find tangent of alpha plus beta, I could use parts A and B, and I could actually divide them, right? Because that's sine of alpha plus beta. This is cosine of alpha plus beta, and I could divide the first fraction by the second one. I could do that. Make sense? So that's one way of doing this problem. But I wasn't asked to find the addition one. I was asked to find the subtraction one. And I didn't do both sine of alpha minus beta and cosine of alpha minus beta. I only did one of them. So the only thing I'm left with at this point, aside from going and finding cosine of alpha minus beta and then dividing them, would be to use the formula for tangent. So they structured that, of course, on purpose because they want to see that you can use the formula, and I'd like to as well. The formula is not quite as clean or easy to use. So let's take a look. We've got tangent of alpha minus beta. What is that formula telling me to do? So somebody go back and take a look at that one for me.
Tangent of alpha minus tangent of beta over 1 plus tangent of alpha, tangent of beta.
Thanks, Brad. Okay, let me move that up a little bit. All right, so here's my formula. And I know all those pieces because we found them on the very first slide. So what is the tangent of alpha? Good, negative square root of 3. And what is the tangent of beta? Right. And then I have 1 plus, and I've got those two values multiplied now. So negative square root of 3 times square root of 2 over 4. All right, so anyone want to guess what I would like to do as my first step?
On the denominator at top.
Even better, Lauren. I want to get rid of the denominators. And I multiply by 4. Yes, so I want to find out what the common denominator would be, and then I want to multiply by it so that I won't have any more little denominators to deal with. So I can do it like this. So this gives me negative 4 square root of 3, and then minus square root of 2, right, because we're distributing. Everybody with me on that? And we'll do it in the denominator as well. I won't draw my lines so it won't run into things, but I have 4, and then I have a negative because I've got the negative square root of 3, and then I have square root of 3 times square root of 2, which is square root of 6. Yeah. Now, you might be tempted to think you're finished, but you're actually not. What's wrong at this point from keeping me being finished? I've got a radical on the bottom. And we encountered this, at least in this class, for the first time last class period, where we had a radical in the denominator, but that wasn't just the radical in the denominator. It had some addition and subtraction involved as well. Do you remember what we did to handle that? We multiplied by the conjugate. And the conjugate is the same value that the denominator is, but what's different? The sign in the middle. Excellent. I'm glad you guys were all with me last week. All right, so here's what we've got, right? And of course, if I do that to the denominator, I have to do that to the numerator, and I'm less happy doing that to the numerator because it makes a mess, doesn't it? Yeah, it does. The denominator, it makes it prettier, cleans it up, it eliminates the radical, all that's good stuff, but the numerator, it makes a mess. So let me put parentheses around the numerator just to remind ourselves that we actually do have to FOIL this out for real. So my first term, what is negative 4 square root of 3 times 4?
16 square root of 3.
Right? And then, so that's my first term, F-O-I-L. So outside for the oil part, the O, that's negative 4 square root of 3 times square root of 6. What do I get?
4 square root of 18.
18. So we'll go back and we'll simplify that 18 in a little bit, but for now it's okay to leave it. Oh, let's see. Inside terms, we have a negative square root 2 and a 4, which gives me...
Negative 4 square root of 2.
Good. And then my last terms.
Negative square root of 12.
Okay. As ugly as all that is correct. How about the denominator? Do I actually really have to FOIL? I just do the first and last terms and square them, right? That's why I chose what I chose, right? It's because the inside and the outside terms would cancel if we actually did FOILing. So the first terms, 4 times 4 is going to be 16. I do have a subtraction sign, right? Then next, because I've got the negative and the positive. And then what's square root of 6 times square root of 6? 6. So a denominator does not have any more radicals involved, which was the point. Yeah? And it's 10 now. All right. I need to simplify this numerator because some of these can simplify. Obviously, square root of 3, we're stuck with that. But the square root of 18 can simplify. To what? 3 square root of 2. So let's just write this on the side to remind ourselves. 18 is square root of 9 times 2. So this is 3 square roots of 2. So right here in the denominator right now, or in the numerator right now, I've got negative 16 square root of 3. And I have 4 times 3, which would be 12. So I have negative 12 square roots of 2. My negative 4 square root of 2, that one also cannot change, but the square root of 12 can. So what's square root of 12 going to become?
2 square root of 3.
Right, so this is 4 times 3, right? So we have 2 square roots of 3. So I've got minus 2 square roots of 3. which becomes much friendlier because I can combine the square roots of 3 and I can combine the square roots of 2, right? And then this is all over 10. Thank you. All right, so what do we have? Let's see. I have,
Question.
yes,
What happened to the 3 square root of 2?
3 square root of 2 got multiplied by the 4, and 3 times 4 is 12.
Okay.
So I have the 12 square roots of 2 here. Any other questions at this point? Okay. I want to combine this negative 16 square root of 3 and this negative 2 square root of 3 for a grand total of negative 18 square root of 3. How about the square roots of 2? How many of those do I have? 12 here and 4 here. Negative 16. And it's still all over 10. We can reduce. What can we simplify here?
Divided by 2.
That was weird. What was that? I'm sorry.
Divided by 2.
Yeah, they're all 2's, right? So I'm looking at the numbers in front of my radicals. All the numbers in front of the radicals and the number in the denominator are all even. So they can all be divided by 2. And so if I reduce these by 2's, I get a 9 on the first one. What's on the second one? 8, and the bottom is a 5. And that will be my final solution here. So my final solution is a very ugly looking solution, and I'm perfectly okay with that. It's negative 9 square roots of 3 minus 8 square roots of 2 over 5. Okay, it's a lot of work for one problem because it really wasn't one problem, right? It was 4 problems, and they pushed them all in together into one problem so that you could have the same conditions at the beginning. All right, that's why. All right, but the fun continues. Because I told you we were going to do this for 4 sections, right? Establishing identities. Here's the nice part, though. The identities in these last the last 3 sections of the 4 tend to be a little bit more straightforward because you know which identities they want you to use, right? We're in the section that says sum and difference identities, which means you're going to be using some sum and difference identities. Okay, so they tend to be a little bit more straightforward. If there's not as much question in your mind, or there shouldn't be, well, what do I need to use? Well, here I see sine of pi minus theta. Well, I'm working with sum and difference formulas, right? And I've got one that has a sine value of 2 things subtracted. That's the one I'm supposed to use. Okay? So looking at that one, looking at that identity, that is, I'm supposed to take the sine value of theta, or sorry, pi minus theta. So I'm on the right-hand side of number 2, right? The second line, the right-hand side over here. And this says sine of alpha minus beta. So I'm going to have sine of what? Sine of pi, and then what? Cosine of theta. I'm following this formula, right? Is everybody looking at their formula to follow too? Because I don't have it up on the screen at the same time. And then there's a subtraction sign in my formula. And then it says cosine of that first angle, which was pi. And then sine of the second angle, which is theta. So I'm working only on the left-hand side right now. But this is a really good thing because pi is an angle that you know. Yeah? And you know what the sine value and the cosine value are of pi. What is the sine of pi? The sine of pi is 0. I've heard 2 things, but one of them was right. So 0 times cosine of theta. And what is the cosine of pi? It is negative 1 times the sine of theta. So 0 times cosine of theta eliminates itself, correct? So this piece is 0. And then I've got the opposite of negative 1 or negative 1 or subtracting negative 1 or however you want to interpret that. And they cancel each other out too, right? The signs do. So this ends up just being sine of theta, which is exactly what I wanted, right? Was not painful, was it? No, it was not painful. Okay, we have one more. Let's see if I can inflict some more pain. No, it doesn't look too bad either. So let's take a look. All right, it doesn't start out looking so hot. I have sine of alpha plus beta and sine of alpha minus beta on the left-hand side, and I've got some tangents on the right-hand side. You have to decide in your mind right now with me quickly, Which side would be the easier one to work with? The left-hand side. Why would I not want to work with the right-hand side, Janet? We would, or even on the right-hand side, worse than that, if I wanted to use any of those tangent alpha plus beta formulas, that formula was messier to work with. So if at some point I ended up using one of those formulas in there, it wouldn't be so pretty. I definitely want to work with the left-hand side. And you have formulas for sine of alpha plus beta and sine of alpha minus beta. So we're going to use those formulas, okay? So somebody tell me what this formula is for sine of alpha plus beta that will become my new numerator.
Sine of alpha plus sine beta plus cosine alpha sine beta.
Okay? And someone else tell me what the denominator is with the formula.
Sine alpha cosine beta minus cosine alpha sine beta.
And I'm trying to get this to have tangent of alpha and tangent of beta, or tangent of alpha minus tangent of beta, and so forth. And I can't cancel anything, right? Because I don't have any factors common to everything. I can't factor anything out. Do you feel stuck? I feel stuck. Michael looks stuck. Yeah. So as much as I would love to have worked with the left-hand side because it was easy to work with, it didn't end up working, did it? And is that okay? Caitlin's shaking her head, yes. It is, right? That was the one I was drawn to. It seemed like the easier one to work with, didn't it? I mean, we talked about it. Yeah, Jane and I both said it, yeah. Yeah, and it didn't end up giving me anything to continue with. Agreed? Okay, so we're going to take a step back and we're going to try the other side. Okay? So as I do that, I need more space. I'm going to erase. Okay, let's try the right-hand side then and see if that'll get us anywhere we want to go. And when we were talking sort of in theory about the right-hand side, Janet gave a good suggestion. She talked about changing those tangents into sines and cosines, right? Let's try that. Okay? So tangent of alpha would be over cosine of alpha. And then I'm going to do the same thing with tangent beta, but I'm going to do it with betas. So I've got sine of beta over cosine of beta. Oh, and I'm out of time. I've totally run over time for you guys. Let me finish it real quick. We're almost done with it, okay? I've got the exact same thing in the denominator, but subtraction. And as much as I didn't want to do this this side over here, I'm almost done with it. It doesn't look really pretty, but what would I do next? Yes. I told you one of my favorite things to do is to get rid of small fractions, right? That is within a trig sense, not within my entire life. This will eliminate both denominators, little denominators. But you have to distribute it, correct? So the first one, sine alpha over cosine alpha, the cosine alphas cancel and the cosine beta remains. So I have sine of alpha, cosine of beta. And the second one, the cosine betas cancel, so I have sine of beta and cosine of alpha. And the denominator, I've got the same thing going on. In fact, it's exactly the same, except a different sign in the middle. Sine of alpha, cosine of beta, plus sine of beta, cosine of alpha. Or in different order if you want to switch like these two around. Of course, it's the same thing. If you still had the left-hand side written down, you're done, aren't you? I had to erase mine because I ran out of space. If you still have yours done, that's great. If you don't, you just take one more step and you just write out that the top is, in fact, sine of alpha plus beta, and the bottom is, in fact, sine of alpha minus beta. Either way, you're finished at that point, and it wasn't as bad as it looked. Agreed? Right. All right.